Everyone, in this video we're going to look at equivalent fractions. So let's put that heading down. So equivalent fractions. Now what it means by equivalent fractions is basically fractions that are equal. So equivalent fractions are probably helpful because if we were looking at very large fractions, say if we were looking at something like, sorry, I'll just get my pen ready, something like 220 over, say, 560, then it's a very big number to think about. Well, how is that simplified? How can we actually see what that looks like? So when we're simplifying fractions, it's actually the same as doing equivalent fractions. They're still the same. So let's say we put this fraction into some sort of context. So let's say, all right, we surveyed 560 people. And of those 560 people, 220 were Collingwood supporters. All right, so that means the remainder support some other team. So we want to think, well, I kind of feel like that's half of them, but maybe it's a little bit less. So let's simplify it to actually see what proportion of people in this group of 560 actually barrack for Collingwood. So that's why we would simplify. Now this is actually quite a big number to simplify. So what we could do straight away is just drop those zeros. Okay, so I can see that as 22 over 56. It's the same fraction. So basically this could say for every 56 people I ask, on average 22 would barrack for Collingwood. Okay, so same population, but instead of asking everyone again, we could just ask 56 people, and it would be expected that out of that 56, 22 would barrack for Collingwood. But I still know that's not it's the same fraction, but it's not the simplest form. And if I have a look at both of these fractions, they're both even numbers. So I can say, well, I can probably divide this numerator and this denominator by 2, just to make it a little bit simpler for myself. So 11 over 56 divided by 2 is 28. And actually that is the simplest fraction. So the first thing when you're simplifying fractions, it's a good idea to look for the highest common factor, but if you can't, then you just look for a common factor. So when we were doing 220 divided by 560, effectively what I was doing by getting rid of that 0 was dividing by 10. All right, because I knew that 10 was a common factor. But what I could have done was just divided by 20 from the start, and that was my highest common factor. But with fractions, you can simplify using any common factor. It's just a lot more straightforward to do the highest common factor. So we could say this time for every 11 people I ask in the same population, on average, oops, not 11, silly me. It should have been 28. So for every 28 I ask, on average, 11 would barrack for Collingwood. And this is actually, when you think about it, used a lot in statistics. So I know that, 11 out of 28 people barrack for Collingwood. If I was to get a larger population, so bigger than 560, so let's say they said, well, how many in a group of, the MCG holds 100,000 people. So if I just put in 100,000 people at random into the MCG, how many would barrack for Collingwood? And we could use equivalent fractions that way. I didn't really use a nice number, so maybe we can think of another number that's a little bit easier. So let's say I chose 28,000, which is a very big number. You're not going to, you can have 28,000 at the MCG. So what did I do to get to 28,000? I could multiply by 1,000. So whatever I do to the top, I do to the bottom. So that gives me 11,000 on top. So there's still equivalent fractions. All these fractions I've drawn here are all the same fraction. All right, they just look different. So 220 over 560 is the same as 22 over 56, is the same as 11 over 28, is the same as 11,000 over 28,000. And you can make whatever equivalent fraction you want, as long as whatever you do to the top, you also do to the bottom. So I could say, well, let's go back to our normal 560 and maybe do 56,000. So that means, what did I do to that 28,000? To get to that 56,000, I multiplied by 2. So whatever I do to the top, I got to do to the bottom. Oh, well, whatever I do to the bottom, I have to do to the top. Same thing. All right, so 22,000 over 56,000. And you can see these numbers kind of appearing at the same time. All right, because we're just doing multiples of them. So let's think of a simpler fraction. So let's think of the fraction 1/2. All right, so it's the most basic fraction, I think. If we were to make an equivalent fraction, we could just say, well, I'm going to multiply that denominator by 2. And whatever I do to the bottom, I have to do to the top. So let's multiply. Oops, that's not a times. Let's make that a times. Whatever I do to the bottom, I do to the top. So 2 times 2 is 4. 1 times 2 is 2. And I could keep doing that, doubling the bottom and doubling the top. And these are actually all the same fraction. All right, they're equivalent fractions. And it's the same as if I had a pizza. All right, so I went ahead and bought a pizza and I just split it in 2. So my friend had this half. She had half a pizza and I had the other half a pizza. So, we had half a pizza each. But maybe I bought the same pizza and it came sliced in 4. But I still had just one friend to share my pizza with. So she had that half. And I had the other half. So you can see they're the same fraction. So just because she had 2/4 and I had 2/4, it's still the same as having half a pizza. So let's look at this 16 over 32, which might be a bit hard to draw. All right, so there's your 4 pieces. And there's your 8 pieces. This is going to be hard to draw. I'm going to draw your 16. Maybe we'll stop at 16 because it's a bit hard to draw, probably draw for 32. So there's your 16 pieces. So we're looking at this fraction here. All right, so we've got 1, 2, I'm not drawing them around the right way. Can we kind of clear that? Let's draw them on the right way. All right, so there's 1, there's 2, there's 3, there's 4, there's 5, there's 6, there's 7, there's 8. All right, and let's draw the other side. 1, 2, 3, 4, 5, 6, 7. Oh, did I miss one? So I knew that was going to happen. 1, 2, 3, 4. 1, 2, 3, 4. I'm going to get rid of that one. Oh, I got rid of the whole thing. There we go. Start again. 1, 2, 3, 4, 5, 6, 7, 8. All right, so you can see they're all the same portion of the whole. All right, it's just that your number of pieces of that whole has changed. Now, if we had a different fraction, so a more complicated fraction than a half, so let's say we had 3/5. If we wanted to look at any equivalent fraction, We just have to change the numerator and the denominator. So if I wanted to, let's say hypothetically, times that by 2, whatever I do to the bottom, I have to do to the top. So 5 times 2 is 10, 3 times 2 is 6. So they're the same fraction. So if I had my pizza split into 5 pieces, now this is a bit harder to draw. All right, so there's my 5 pieces, and my friend was a little bit greedy, so she had 3, and I had the other 2. So I can draw pretty much the same thing. You know, obviously this is not to scale, but you get the gist. So there's my 3 out of 5, but if I was to halve every piece of pizza, so let's say I had more friends come to the party to eat pizza, and I'm like, well, hey bestie, I have to split these 5 pieces into half, otherwise everyone's not going to get some pizza. So if I go ahead and split each piece, we now get those 10 pieces. But she's like, oh, I really want my equivalent of what I was getting before. So she still gets her 3/5. There's her 3/5 there. All right, you can see I've shaded 6 pieces. And then if I shade the yellow, all right, there's your 4/5, which is the same as, 4/10, which is the same as 2/5. Now, to make more equivalent fractions, I can multiply the bottom by whatever number I like. I don't have to keep doubling. I could make it 10. All right, but whatever I do to the bottom, you just have to remember to do to the top. So 10 times 10 is 100, 60 times 10 is 60. And you could change any of them. So I could go back from the 3/5, let's go all the way over here, and let's multiply it by 12. All right, so 5 times 12 is 60, and 3 times 12 is 36. So another equivalent fraction, all right, it just looks different if you were to draw it. Well, I shouldn't say different. They look the same, all right, but you've just got more parts that you're kind of shading. All right, just trying to think if there's anything else I wanted to add to that. No, I don't think so. So, bye girls.